In this video, I want to talk about Node, which is a JavaScript environment outside of the browser, and I want to write some Node code together. And this we are learning so that we understand Electron, which will allow us to build desktop applications, or frameworks like Ionic, which will allow us to build mobile applications with our web technologies. So Node is a JavaScript runtime. So it is an engine that can take in JavaScript code and execute it. It is based off of a thing called V8, which is Google's open source high performance JavaScript engine. So this is the engine that exists inside the browser that takes in JavaScript code and knows how to compile and execute that JavaScript code. So Node is based off of that. So it has that V8 engine under the hood. So we can feed in JavaScript to it and it can execute that JavaScript. But a couple of things are important to note as we're moving from browser-based JavaScript to Node-based JavaScript. When we make this move, we lose a lot of the things that browsers can do. So we're going to lose some of the browser APIs. So for instance, I have this page pulled up that just has a few of them listed. So there's no document object model, there's no page that we are inserting HTML into in our Node environment. So we're not going to be able to say document query selector and put things on the page, access elements from the page. That doesn't exist inside of Node. There is no local storage. There's no canvas. There's no audio API. So a lot of the features that exist within the browser don't exist inside of Node. But Node does come with a bunch of extra features that are really useful for the applications where you might use Node. So for instance, if I go to the documentation page here for the latest version of Node, I can see some of the things that Node provides. So it provides a console class so that you can output things to a terminal window. It has a file system class that allows you to, I should not say class, it's a part of the API here, so a module within the API that allows you to read and write to the file system. So these are things that we couldn't do in the browser, but now we can do because we're outside of that browser environment. It also has ways for you to make HTTP and HTTP requests and set up servers. So you're able to talk to some API like the Pokemon API and pull data from it inside of a Node application, but you can also create your own server that listens for requests and responds to those requests. So you could create your own API that sort of stores some data in a database, and then when people request it, it grabs that information from the database and gives it back to the user. And then there are modules here for other things like reading from the operating system, forming file paths, etc., etc. So we're making this trade. We're leaving the browser environment, which means our code is going to be able to run in more places. But because we're leaving the browser environment, we're going to lose some of those browser APIs. And we're going to gain some different types of things that we can do, like interacting with the file system. And this is going to enable things like we can write code for scripting and automation. So we could write a Node script that goes and talks to like our local city's train API to pull down when the train is going to be, the train schedule for our day, and display it on our desktop every time we log in. Or we could write a Node application that reads in a bunch of weather reports for the last decade and calculates some statistics like the average temperature on each day. Also in this bin of like scripting and automation are things like Create React App. So Create React App actually uses Node to build our project. So when we're saying npm run start, we're actually running some Node code. In addition to the scripting and automation, this also opens up the world of servers. And this is actually what this example is here on the About page, is a mini HTTP server. So it sets up a server that's running on this IP address, which is your local host, on port 3000. And this is a really simple server that anytime it gets a request, it sends back hello world as plain text. And so if you ran this Node code, which we'll do shortly, inside on your computer, using the Node environment, you would then be able to go to your browser and go to localhost port 3000 and see the result of this server. So you'd be sending a request to this Node application and getting a response back that you see in your browser. So by moving from JavaScript to this Node environment, it opens up all of these possibilities for what you can do. Okay, a couple of setup things that we want to do before we jump into this, which everyone should probably have done at this point in the first code sprint, but we're going to run through it again here. So I want you to grab the latest version of Node and install it. So you should have 14.15.1. And then if you open your terminal and you type in node space -v, it should print out, if you have installed Node correctly, that version number. So I want everyone to be on the 14 version of Node. So if you don't have that version, just download the latest one and install it. And I also want everyone to have a consistent development environment for their terminal window. So if you are on Mac and Linux, then you're all set. You already have a nice terminal application that comes packaged with the operating system. If you're on Windows, then you want to make sure that you have Git Bash installed. So if you Google search Git Bash, I'll also make sure that this is linked. Download this and install it. And then when you open up your terminal window, instead of just opening CMD or PowerShell, you'll search your computer for Git Bash, and you'll get an application window that looks like this. My terminal window here, it's just a different GUI for accessing it, but it's actually running this Git Bash under the hood. So once everyone is on the same environment, you should be able to run commands like ls to list all of the things that are in your current directory. And then the last setup that I want folks to do is open up Visual Studio Code. And we're going to be using our integrated terminal window here. And we want to make sure that this terminal window is using Git Bash if we're on Windows, or your default terminal if you're on Mac or Linux. And so what I'm going to do here is hit Control-Shift-P to open up my command prompt. And if I search for terminal, I'll see a few completes here. The one that I want is terminal select default shell. And then it's going to detect some of the ones that I have installed on my machine. And I want to make sure that I am running Git Bash as my default shell inside of Visual Studio. So I'll select that, and then I'll make sure that this drop down here says bash, which is telling me that's the environment that I'm in here. So I should be able to run commands like ls to list all of the things in my current directory. Okay, so we should have the latest version of Node, we should have our terminal window set up, and we should also have Visual Studio configured at this point to use our terminal window. Folks on Mac and Linux probably won't have to do much configuring here, but if you're on Windows, you'll want to make sure you have Git Bash and that you've configured Git Bash to run. First thing we're going to do is just open up our terminal, so that'll either be Git Bash or your default terminal, and then just type in node without anything else. And what this starts is a REPL environment, which is an environment where you can run individual lines of code and Node will go ahead and execute and give you the result. So if I type some math in here like 2 + 3 and hit enter, it is going to run that piece of code through the JavaScript runtime and give me back the number 5. Or if I do something like console log hello and execute it, it is going to print hello to the window here. We're also going to see undefined because that's what this function returns after it finishes executing. And then to exit this, well, actually, we can use the help command here. So if we do help, we can see a couple of things that show up here as things that we can do. So we could save and load some commands, or if we type .exit, we can exit the REPL environment. So that's what we want to do. I'm going to type in .exit, hit enter, and I'm out of that environment. So that was Node. We just took Node, we gave it some code, we had it execute. It wasn't terribly convenient to do this, but for writing large amounts of code, but for small amounts of code that we just want to like test out, this is kind of a cool thing that we can do. But now we want to move from doing this from our terminal to doing this inside of Visual Studio. So we'll write a JavaScript file that then we can feed in to Node and have Node run. So I want to close this. I want to go to my folder here for Code Sprint C, week 3. And I'm just going to create a new folder. And let's call this Node Demo. And then I'm going to open up this folder in Visual Studio by right-clicking Open with Code, or you could just go ahead and get a blank Visual Studio window open and drag your project in there. And you can see now over on the sidebar here, I should see the name of that folder, so I can add some files to this project. So if I come over here, click New File, index.js, or, that's fine, we'll leave it at index.js. Now we could put some code in here, like we can use the console class that comes packaged with Node, and it has a lot of things that we're familiar with, like console log. So we can say, hello, give it a save. And now to get Node to execute this file, what we want to do is pull up our terminal window here, which should be located in my Node demo folder. That should be the path here. And if I do ls, I should see my index.js listed here. So when we ran Node, we could run Node without anything. It would open up a REPL environment where we can run individual lines of JavaScript and get the results. If we did -v, that would be running the command to tell us which version of Node we have installed. And if we do Node and then give it a file name, it will go ahead, load whatever's in that file, and execute it using the Node runtime. So if I say node index.js, making sure that I'm in that folder where index.js is, and give it a run, now we can see console log printing out. Could come back in, write another console log, give it a save, rerun it, and now we should see both of those things printing out. So however much JavaScript we want to jam into this file, Node will happily chug away at it and run it when we tell it by specifying the file name like this. So let's intentionally make some mistakes before we move on. So when we were working with the browser, we would see errors from our Node code show up, or from our JavaScript code show up in our browser console. Where we're going to see the errors show up inside of the Node environment, we're going to have our Visual Studio errors, like down here. If I pull it up, it'll show me all the errors that are being generated by my configuration of Visual Studio. So some errors will be caught by that. But if we have a runtime error, Visual Studio is not going to be able to check those, and we're going to have to try and run our code to see those. So here's an example. Let's say we didn't catch this in our editor, or this was actually a sneaky runtime error that we didn't know was going to happen until we ran it. We would see our error print out here. So we would be told, here's the file, here's the line number, it's on line 2, here is our place where the error was encountered, and it's highlighting this string and telling us that there's an invalid or unexpected token. And then it gives us our stack trace like we saw in the browser, where it tells us, where was this encountered in terms of the stack of code that was just executed. And since we're in one file, there's not a lot here. Most of this stuff is, actually all of this stuff here is internal to the Node engine. So not a ton that's helpful for us right now, but as soon as we move to more complicated applications, this would have a stack trace that would be quite useful for us to investigate. Okay, so we know here's our error. We'll go ahead, we'll give that a fix. We'll close the quotation, close the string with the quotation mark. Let's try a different type of error. Like maybe I say, go ahead and run main.js, which doesn't exist inside this folder. So if I run it, it's going to tell me cannot find module, and then it's going to tell me the path where it was looking. So it was looking in our node demo folder for something called main.js. So this error is telling us that, the loader for Node could not find this file that we requested it load. Okay, we've got our first Node code running here. We figured out how errors are going to show up. We're not going to have a console window in a browser because there is no browser here. For us to see those errors, we're going to have to run it to see the errors. And the next thing I want to do is dive into some of those features that Node provides that you don't have inside of the browser. So the thing that's going to be really useful to keep handy is the Node documentation page. So if I go to the Node homepage and I see here's the version I'm working with, 14.5.1, there's a little API docs link here. If I click on that, that will take me to the documentation for this version of Node that I'm using. You want to be careful to be looking at the docs for whichever version you're using. And since we're using the LTS, the long-term support version, not the current version, which is not the long-term support version, but is the latest version, if I click on docs, I can see that there are two links over here on the sidebar. There's one for the 15 and one for the 14. So if you're just generally Google searching for Node documentation, you may end up on this 15 version, even though you're not using Node 15. So you want to make sure that you're looking up the right version of the docs. So here, let's go to the Node 14.15.1, and let's start with an easy module, the OS module. So this module provides, we can see in this table of contents, a bunch of things that are related to the operating system. So we can actually get information about the CPUs that are running on this machine, the platform, like Windows versus Mac versus Linux, and the release of that operating system. So the way that this works, if we keep scrolling down, the first thing that you'll encounter is a description of the module itself. So it's telling us it provides operating system related utility methods and properties. And the way that you can access it is by importing it using this funky syntax that is different than the way we imported modules in the browser. So here, instead of saying import OS from OS in quotation marks, we're going to say const OS equals require, and then put the name of our module inside of parentheses. And then once we import that, we'll be able to use any of these properties like os.eol or any of the methods like os.arch, which would give us back here, it's telling us it gives us back a string and tells us the CPU architecture. So is it ARM, is it ARM64, etc., etc. So let's go ahead and get the information about the operating system that's running. So a couple ways, you can just sort of like scan and scroll to look through things, or if you go back up to the table of contents and you look, you can try and find the matching property or method name, and you can tell if it's a property or a method, whether there are parentheses after it. So property, method, method. So let's look for something that would tell us which operating system we're on, which would be os.platform. So if I click on this, it's going to take me down to the description for this method. It's telling us that this returns a string and returns a string identifying the operating system platform. So here are the possible values: AIX, Darwin, FreeBSD, Linux, OpenBSD, etc. And we can also see down here there's a version of Android if if Node was built on the Android operating system. So we're going to need to import that OS module and then run this platform function, and we'll get back a string that we can print out. So if we flip back to Node here, let's do our imports at the top. So let me show you what this would look like in the browser, which is not how it's going to look here. Let me clear this. So in the browser, we would do something like this: import OS from OS. But in Node, that support for this import syntax is experimental, and we're not going to be using it in this course. So we're going to go ahead and do this form of importing. And if you're Googling and encountering things, this is common JS imports, and this is the syntax for ESM or ECMAScript modules. So this is the form that we're going to be using, where you can see it's very similar. Instead of saying import OS, we say const OS. And then when we're saying where that's coming from on the right-hand side, we said from OS. Here we're saying, let's call this require function and give it the name of the module in our as a parameter here in as a string. So we're passing in quotation marks OS. So then we could actually ask for that platform. So we could say OS dot, and you can see that inside of Visual Studio, it's configured with IntelliSense to know what comes from that OS module. So if I go ahead and look, I can see, oh, here's that CPU's one. Or if I start typing platform, I can see, hey, here's that platform function. So if I run it, it'll give me back a string that then we could print out. So we could say console.log, and let's use a template string. You are running node on this platform. And then go ahead and run node index.js. And we should see, hello, I'm outside the browser. You're running on this platform, Win32. And since I'm running on a Windows machine, that's why I'm seeing Win32. If you're on a Mac, you'll see Darwin. If you're on a Linux machine, you'll see one of the strings that corresponds to the flavors of Linux machines. But here we're doing something that we couldn't do inside the browser, where we're actually like inspecting something deeper about the operating system that we're running within. And when we run JavaScript inside the browser, it's kind of the sandbox environment to protect users who are viewing JavaScript in the browser to make sure that that code doesn't do anything insecure and sort of mess with things on your file system. So we're outside of that sandbox environment, so we're going to have access to more things. Let's print out a few more. So here, if we go back to the OS, let's look at the version number, and maybe we'll print that out. So if you check out the documentation for this function, returns a string in identifying the kernel version of our operating system, and then down here it tells us some information that it uses this piece of software or this command uname, and on Windows, here's the function that it uses, and some more information here. So these are going to be some implementation details of how this command runs on the different operating systems that Node runs on. So let's grab our version by running that version function from our OS module, and then we can print out something really similar here. We can say you are running Node on this version. Give it a rerun, and we can see, hello, I'm outside the browser. You're running Node on this platform, and here's the version that you're using. And for me, I'm using Windows 10 Education. Okay, that's enough of the operating system module. Let's dip our toes into the file system module, which allows you to read and write to the file system of the computer that Node is running on. So here you'd be able to create text files on my computer or on your own computer as you were running Node code, or read files from your computer. So if we come back here and on the sidebar, we can navigate to the different modules. Here we're in the OS, but if I click on file system, that'll take me to the table of contents for this file system. Click on the file system here, we can see the FS module enables interacting with the file system in a way that is modeled on standard POSIX, which is the portable operating system interface. So we import that module, FS, and then we are able to use anything from that FS module. So we can see a bunch of examples of methods here that are coming from that module, like open, opendir, read, readdir. And if I scroll back up to the top, there were a couple of examples, and and other pieces of information at the top of the module. So here we can see a synchronous example of interfacing with some piece of the FS module. So this is attempting to delete this folder or this file, temp hello, and doing a try catch around it to make sure to catch any errors. And then it's also giving us some examples of, hey, if you're trying to do it asynchronously, here is the callback way of doing that. And here is the promise-based way of doing that. So we're not going to dive too deep into the file system module. We're going to scroll up to the top, and really all we're going to do is try and read a file in and print it out. So we're going to look through the documentation here to try and find something that looks like it works. And we can see, here we've got read, another overload of read. So it's the same function, but with different numbers of parameters. We have readdir sync, and read file sync. And we're going to stick with these. These are the ones that we want for reading an individual file. And there's read file and read file sync. So this is getting to what we're seeing with those two examples, is that there are synchronous ways to do some things, and there are asynchronous ways to do some things. So if we go to read file sync, we can get a description of what this does, and then we can compare it to the async version. So read file sync takes in a path, a buffer, a URL, an integer that represents the file, how to locate that file. So we're going to be using a string to pass in a path to where a file is located. And then you can pass in either an object or a string to configure some of the options for reading whichever file you're reading in. So encoding allows you to say what character set this is encoded with. The files that we're going to be reading in are UTF-8. And then gives you some options for flags, which configure how that file is opened. So if I click on the link here, we can see A would open it for appending, and R opens it for reading, and R+ opens it for reading and writing. So passing these flags in will give you more control over how that file is opened. For us, we can leave it as the default R, which just opens the file for reading. And you can see here, there's our default specified next to the flag variable. So path options, those are what we can pass in. And then returns here tells us that it's going to either give us back a string or a buffer. And so in our case, when we're reading a text file and we're saying UTF-8, we're going to get back a string. But if we were reading a file that's not a text file, like a binary file, we would get back a buffer. So this is going to return the contents of whatever we pass in at that path. And then we get a bit more information here about encoding and what happens if you try and read a path that's a directory. So this is our read file sync version. So this means it executes synchronously. So as soon as this line of code is hit, our code or the Node engine will go ahead and grab that file, read all of it. If it's a huge file, that means that nothing else is going to run while Node is chugging away at that big file. When you get deeper into Node, you'll often want to use the asynchronous versions of these. So we can even see a note here that tells us, for more information, see the asynchronous version of this API call, which is the read file. So this one doesn't return something to you, but instead you pass it similar information, the path, the options, and then you also pass it a callback, which is a function that will run, when this thing has executed successfully or when there's an error. And you can see an example of that here. So here we try and read a file, pass in a function that has two parameters, error and data. This function will be called if there's an error. And it'll also be called when the data is returned. So then inside of that function, you want to check, hey, was there an error? Let's go ahead and handle that error. If there was no error, let's go ahead and just do whatever we were going to do with that data. So this asynchronous version, when we start reading the file, you could have multiple lines of code below this that would continue to execute while that file is reading in the background. So our read file sync is going to be synchronous and is going to block our code, the rest of our code, from executing until the file is done. being read, and then our asynchronous version, read file, is not going to be blocking and is going to use this callback base structure for telling us when that file has finished reading. You'll see a lot of that inside of Node, the kind of asynchronous and synchronous versions, and generally you want to use those asynchronous versions. For just learning for this demo, we're gonna stick to the synchronous version here. So we're gonna do read file sync. So let's flip back to Node here. So we're in our Visual Studio project. Let's create a new text file and let's call it message.txt. And let's go ahead and put like a movie quote in here. So how about we use, well, let's use Star Wars. So may the force be with you. And that, I think, was 1977. So we'll save that message.txt file. And then over in our index.js, we're going to bring in that fs module and use our read file sync method to go ahead and read the contents of that file. So we are going to import it using the common JS syntax here, which I'm going to say const fs equals require fs. And same deal with our import structure. We don't have to call this fs. We're doing that just to simplify our naming, but we could call this file system. It would be a bad idea, but we could call it pizza, and that would be fine as long as we used that variable name elsewhere in our code. We're just defining a variable up here that is equal to whatever is exported from the fs module. So let's get our docs, read file sync. We're going to pass in that path as a string, and then we're going to give it an options object that specifies our encoding to be UTF-8. So let's go ahead and read the contents of the file. So let's say our message is equal to fs.read file sync, and the path, we can just pass in the name of the file because this exists in the same folder as our index.js, so we don't have to specify a terribly long path here. We can just put the name of the file. And then our object here has the encoding property that is a string, and you can see that my IntelliSense is popping up options here. So we want UTF-8 to indicate that this is a Unicode file. And then we could specify our flag as well. And we'll do that for completeness, but we can also see the docs here are telling us that it defaults to R, which we also saw in the docs here, that the flag defaults to R, which means that the file is just being opened for reading, not for writing or appending. So let's give this a save, and let's print this out. You've got a message, and let's turn this into a template string and go ahead and drop our message in here. Give it a run. And we can see here's our operating system information and here's our message. May the force be with you. Oops, got an extra space here that I'm going to get rid of, save, and rerun. And now that extra space is gone. That looks better. And if we had made a mistake here, like we forgot the extra T here in the file extension and tried to run it, we would see our Node application crashes and we're getting this error printing out. No such file or directory, message.tx. It's telling us where this was thrown. It was in the file system utils.js at 308. Here's our error message and our stack trace, which tells us the sequence of functions that were run to generate this error. And we can see here highlighted is our code, index.js, line 14, column 20. So with Node, you're going to want to run your code to make sure you're getting those error messages, seeing them print out. So let's fix that, make sure that we got it running again, all good. So that's, a good introduction to a couple of those modules. With the FS module, you can do a lot more. Like you can actually write to files and append to files. And with some of the other modules, like the readline module, you can get input from your terminal window. With the HTTP module, you can make HTTP requests and talk to a server to pull some data back, or you can create your own server. There's a whole lot that you can do here. We're just kind of scratching the surface. And before we wrap up, I want to grab that HTTP server example and run that and make a few simple modifications, and then want to introduce npm back into our projects, which we have used previously. Okay, so we're going to go back to the Node About page here, and this is a working example of creating a server. So I'm going to just copy this, and into my Node project folder, I'm going to go ahead and create a new file, and I'm going to call this server.js instead of index.js, and go ahead and paste this in and give it a save. And so we can now run this example to get an HTTP server set up. So to run this, we're going to have node and then the name of the file we want to run. So instead of index, we're going to do node server.js and hit enter. It's going to print out this message that the server is running on 127.0.0.1 port 3000, which is your localhost port 3000. And in Visual Studio, you can hover Alt-click to get that to pop open in the browser. And you can see that this returns to you the text hello world in your browser. And it doesn't matter, what URL you go to, it is always going to give you back hello world. So we've got this server that's listening on this IP address, our local host, and this port 3000. So let's look at that code example one more time. So this is using a different module, but it's the same syntax. So we're importing the HTTP module. We are creating two JavaScript variables, one for the host name, which is that IP address for localhost, and one for the port where this application will be hosted. Then we have in the HTTP module, we have reached in to use the create server function, which takes a function that has two parameters. It has a request and it has a response. And the request is, whatever is being sent from the browser. So when we go to the browser and we try to access this, the browser is sending a request to our Node application. It's telling us, hey, give us back this resource. Let's make this a little bit easier to read. So it's talking to that server and saying, hey, give me /home. And then the server is responding with hello world. So the request variable here has information about what has just been requested, and the response is where we set up like the status code to say 200, it's okay. Here's a header where we're sending back some text content, and then res.end is saying here's the content, and finish the response and send it off to the browser. So we're sending back hello world. So this server is essentially this one function that gets run for every request that comes in. And then the server is booted up down here at the bottom using the listen method, where you specify the port and the host name here. And anytime it finishes booting up, it is going to print out this message to the console window. So we could modify this if we wanted. So instead of saying hello world, we could say hey there, and then we could actually use the request variable to print out, what URL they requested. Hey there, you asked me for, and then use the request.url. Then I'm going to go ahead and kill this by hitting Control-C to stop that server from running. So this node script was running that whole time because we had this server set up to just constantly be listening for requests. So Control-C is killing it, and then I can hit up to bring my last command back, which was the node server command here. Hit enter to start it running, and go back to my browser and run it, and we've got the new version of our server that we're talking to here. So here we get that new response, and it's telling us what URL we requested. So if I change it to /books, that server is now responding and knowing that we were asking for books. So this is a really, really simple server, but helps illustrate some of what you can do with Node that we couldn't do with the browser. So inside the browser, we couldn't spin up a server. But here now we have a server that we could go deploy to a platform, and it wouldn't do much that's interesting, but it would be a server that you could then hit from your browser. So if we hosted it on some service, it would no longer be on our local host, port 3000. It would be on some domain that we had set up somewhere where you could talk to it, and it would just echo back to you whatever you were asking for. Not a super useful server, but an example of a server. Okay, and the last thing that I want to do here, let's go ahead and let's kill this. I'm hitting Control-C. What I want to do is bring back in npm to what we've been doing here. So far we have just been using Node, and the way we've been using it, we've just been feeding it one file. But if we bring back in npm, which is that package manager, we could have a bunch of modules that we bring in, that we install using npm install, and store them along with this project. And we can also set up scripts that allow us to execute commands. So we wouldn't have to say node server.js. We could set up a script that runs that server. So what we want to do is initialize this project with npm. So if we type in npm init, this will initialize our project. And if we do npm init-y, this will just fill in all the fields of our package JSON with some defaults. So if I hit enter, it tells me, hey, I just created this package JSON file. And let's take a look at it over here in our browser, or sorry, over here in Visual Studio. So this is a package JSON like we've seen with our Create React App projects. And it specifies some information about this project. So here we've got a name that's filled in with our directory. We've got a version number, which it defaults to 1. We've got a spot for a description. We've got a spot that says, what's the main file that should be run here. We've got a spot for scripts, which are commands that we can kind of set up to run. In our other projects, we also had a list of dependencies, and then we've got keywords, author, and license. For what we're doing here, we really are just going to focus on the scripts, which will allow us to set up some commands that will run Node for us. And let's go ahead and just delete the ones that are in here and start from scratch. So this is a JSON file, so it follows our JavaScript object notation syntax, where you're going to have a key and then some value over on the right-hand side. So here the key is name, colon, and then the value over here. And so scripts is this object that can have a bunch of different script commands registered. So we could call one start, and then over on the right-hand side, we can put in a command that we want to run when we run this start script. So maybe we want to load up our index.js. So we could say node index.js here. And then rather than in our terminal having to say node index.js to run that file, we can just say node run start. And this is going to execute anything that we put over here. What did I do wrong? Oh, whoops, sorry. It is not node run start. It should be npm run start, since we are talking to our package JSON here and the scripts that we've registered in there. So npm run start goes ahead and kicks off that command, which here it's a really short command, but in the future we'll see that these can be much more complex commands. So we've got one that's running our index.js. And then let's create one that runs our server. So we could have a serve command here that runs node server.js. And let's go ahead and npm run serve. Which we can see here ran our node server that we had set up here and started off our server, which we should be able to alt-click and check out in our browser. Still running. Okay, let's flip back. I'm going to Control-C to kill this. And looks like the terminal is bugging out, so I'm just going to hit the kill terminal switch over here. Let's just review before we sort of take the next step into the world of Electron, because Electron is based on this stuff that we're doing here. So we learned about Node, which allowed us to write these JavaScript files outside of the browser and run them outside of the browser. So the Node environment is a JavaScript runtime. It doesn't have any of the browser APIs like local storage, the document object model, but it does have these other features like these modules that come with Node, OS, FS, HTTP, that allow you to do things that you couldn't do in a browser environment. So this allowed us to do things like read and write from files, but it also allowed us to do things like create our own server that listened to HTTP requests and responded with a little message here. And from there, we brought back in npm. So we used the init command to give us a package.json, which has information about this project. And then specifically, we were setting up some scripts so that we could set up commands to run in our terminal under these names. So we could just say npm run start, and that will always run this command, or npm run serve, and that will always run this command. Okay, so with this basis in sort of Node and setting up scripts, this will give us a good scaffold for then stepping deeper into the world of JavaScript outside of the browser. So we'll be able to use Electron, we'll be able to use some other frameworks that allow you to package up web applications as mobile applications, and this, if you want, could take you into the world of building servers. So writing server code that you deploy that talks to a database, that sets up the sort of like server logic for a multiplayer game, all sorts of stuff. So this is opening up a lot of paths forward where you can use JavaScript in different environments for different purposes outside of the browser.